Somewhere above the English Channel on a cold morning in June 1943, the sky erupted with tracers and cannon fire. Flight Lieutenant Edward Watkins of the Royal Air Force 611 Squadron pushed his Supermarine Spitfire Mark 9 through a climbing turn, the Merlin 61 engine roaring at full combat power. Below him, the French coastline stretched like a grey ribbon between sea and cloud. Above him, a formation of Messerschmitt Bf 109 Gustavs descended in a classic bounce manoeuvre, their yellow noses cutting through the morning haze like predatory wasps. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. Watkins had been flying combat missions for 18 months, long enough to recognize when the odds had turned decisively against him. His wingman had already peeled away, trailing smoke after taking cannon strikes during the initial engagement. The fuel gauge showed less than 30 minutes remaining, barely enough to reach the English coast if he turned now and ran at full throttle. But 3 more Spitfires from his squadron were still engaged somewhere in the maelstrom of turning, climbing, diving aircraft, and abandoning them meant condemning those pilots to face overwhelming numbers alone. He rolled inverted and pulled through, watching the horizon spin as he searched for threats. A Bf 109 flashed past his canopy, close enough that he could see the pilot's leather helmet and the worn paint on the fighter's fuselage. Watkins snap-rolled right and fired a 2-second burst, seeing strikes sparkle along the German fighter's wing route before both aircraft hurtled past each other at combined closing speeds exceeding 600 miles per hour. There was no time to observe results, no opportunity to confirm the kill or even verify damage. In the chaotic knife fight of close-quarters aerial combat, survival depended on constant motion, endless vigilance, and the split-second recognition of fleeting opportunities. But this morning, those qualities would not prove sufficient. A burst of 20mm cannon fire from a Bf 109 he had never seen stitched across his Spitfire's left wing, punching fist-sized holes through the thin aluminum skin and severing control cables. The aircraft shuddered violently as hydraulic fluid sprayed across his canopy, turning the world into a red-tinted blur. Watkins felt the stick go slack in his hand, the ailerons no longer responding to his inputs. The Spitfire began a slow, uncontrolled roll to the left, its nose dropping toward the wavetops 4,000 feet below. He tried to correct the roll with rudder alone, stamping hard on the right pedal, but the damage was too extensive, and the aircraft's flight characteristics too compromised. The Spitfire was dying beneath him, its elegant aerodynamics reduced to struggling awkwardness by battle damage that had transformed a precision instrument into an uncontrollable piece of wreckage. Watkins had perhaps 30 seconds to make the most consequential decision a fighter pilot ever faces. Stay with the aircraft and attempt a controlled crash landing, or bail out immediately and take his chances in the channel's cold waters. The altimeter unwound rapidly as the Spitfire descended in its uncontrolled spiral. 3,000 feet, 2,500 feet. The French coast was directly below him now, close enough that he could distinguish individual buildings in the small villages that dotted the Norman countryside. If he was going to bail out, it had to be now, before the altitude dropped too low for his parachute to deploy properly. But something in Watkins's pilot instinct told him the aircraft still possessed enough controllability for a crash landing if he could just maintain enough airspeed to keep the rudder effective. 2,000 feet, 1,500 feet. The decision made itself through the simple passage of seconds and the relentless pull of gravity. He was too low to bail out safely now, committed by circumstance and the dwindling altitude to riding the damaged Spitfire down to whatever conclusion physics and terrain would provide. Watkins scanned the ground below, searching desperately for anything that resembled a suitable forced landing site. The Norman countryside offered a patchwork of small fields divided by hedgerows, narrow roads lined with trees, and scattered farm buildings with their tile roofs and stone walls. There, perhaps half a mile ahead, a rectangular field that looked recently harvested, its surface relatively smooth and free of obvious obstacles. Watkins nursed the crippled Spitfire toward that field, using throttle and rudder to maintain something approximating controlled flight. The Merlin engine was still running smoothly despite the battle damage, its 12 cylinders delivering over 1,400 horsepower through the four-bladed throttle propeller. That power gave him options, allowed him to stretch his glide and maneuver toward the field, rather than simply accepting whatever terrain lay directly beneath his flight path. 500 feet, 300 feet. The field rushed up to meet him with terrifying speed. Watkins chopped the throttle and pulled back on the stick, trying to flare the nose up and bleed off airspeed before impact. The Spitfire's main wheels touched French soil with surprising gentleness, the battle-scarred fighter rolling smoothly across the field for perhaps 50 yards before the damaged left wing dipped, catching the ground and spinning the aircraft violently to the left. The world became a confusion of noise, impact, and disorientation as the Spitfire ground-looped across the field. Metal shrieked as the fuselage scraped across the earth. The propeller disintegrated in an explosion of wood splinters as it struck the ground at full rotational speed. The tail section broke away, tumbling end over end across the field before coming to rest against a hedgerow. And then, finally, silence broken only by the tick of cooling metal and the hiss of escaping hydraulic fluid. Watkins found himself hanging upside down in his harness, the Spitfire having rolled completely inverted during the final seconds of its violent ground contact. His head throbbed where it had struck the gun sight during one of the impacts. Blood ran down his forehead from a gash above his eyebrow, the warm liquid dripping onto the inside of the canopy above his head. But he was alive, conscious, and apparently without serious injury despite the violence of the crash landing. He fumbled with his harness release, his fingers clumsy with adrenaline and the awkward inverted position. The harness released suddenly, dropping him onto the canopy with an impact that drove the breath from his lungs. Watkins lay there for several seconds, gasping, trying to gather his strength and clear his head enough to think about what came next. Escape and evasion, find the French resistance, make his way to Spain and eventually back to England. The training lectures he had received seemed impossibly distant and theoretical now that he faced their practical application. He pushed against the canopy, trying to slide it open, but the frame had been distorted by the crash and would not budge. Panic touched his mind for a moment before training reasserted itself, the emergency canopy jettison. His hand found the red-painted handle and pulled hard. The canopy separated from the fuselage with a metallic crack, falling away and allowing Watkins to crawl out into the French countryside. The field was silent except for natural sounds, birds calling from the hedgerows, wind rustling through grass, the distant lowing of cattle. No sound of approaching vehicles or shouted German commands. Watkins allowed himself a moment of relief before the reality of Tupalo, his situation fully registered. He was down in occupied France, wearing a Royal Air Force uniform that marked him immediately as an enemy combatant, with no weapons, no survival equipment beyond what he carried on his person, and no clear idea of his exact location beyond somewhere in Normandy. He needed to move, get away from the crash site before German patrols arrived to investigate. But first, he turned back to look at his Spitfire one final time. The aircraft lay on its back like a dying bird, its elegant elliptical wings crumpled and torn, its proud fuselage reduced to a broken wreck that would never fly again. Watkins felt an unexpected surge of emotion, almost like grief for a fallen companion. That machine had carried him through countless missions, brought him safely home from situations that should have been fatal, responded faithfully to every demand he had placed upon it. And now it lay broken in a French field, its war finished in a few violent seconds. He turned away and began moving toward the tree line at the field's edge, keeping low, scanning constantly for any sign of enemy activity. Behind him, the wreckage of Spitfire Mark Nine, serial number EN398, began its transformation from frontline fighter to intelligence asset, though Watkins could not know that as he disappeared into the Norman countryside to begin his long journey back to England. The German salvage team arrived within 3 hours of the crash, moving with the practiced efficiency of men who had recovered hundreds of Allied aircraft from crash sites across occupied Europe. Their orders were clear: secure the crash site, assess the wreckage for intelligence value, and arrange transportation to the nearest Luftwaffe facility for detailed examination. This particular Spitfire immediately captured their attention not because of its condition, which was poor, but because of specific markings and features that identified it as something relatively new and potentially significant. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The Spitfire Mark Nine represented a substantial evolution from earlier Spitfire variants that German pilots had encountered since 1940, while retaining the distinctive elliptical wing planform and overall configuration that made Spitfires instantly recognizable. The Mark Nine incorporated critical improvements that transformed its combat capabilities at high altitudes, where bomber escort and interception missions increasingly occurred. The most significant change involved the engine, a Rolls-Royce Merlin 61 with a two-stage, two-speed supercharger that delivered dramatically improved power output above 20,000 feet. This engine development had emerged from urgent operational necessity during 1942, when Luftwaffe fighter bombers began flying high-altitude hit-and-run raids against English targets, operating at altitudes where existing Spitfire variants struggled to intercept effectively. The earlier Spitfire Mark V, which equipped most Royal Air Force fighter squadrons during 1941 and 42, used a Merlin 45 engine with a single-stage supercharger that delivered excellent performance at low and medium altitudes, but suffered severe power loss above 20,000 feet, where the thin air starved the engine of oxygen needed for combustion. German pilots flying the improved Messerschmitt Bf 109 Gustavs and the new Focke-Wulf FW-190 quickly learned to exploit this weakness, maintaining altitude advantage during engagements and forcing Spitfire 5s to fight at a disadvantage or decline combat entirely. The tactical situation grew critical enough that Rolls-Royce and Supermarine rushed development of an interim solution that combined the existing Spitfire 5 airframe with the more powerful Merlin 61 engine. Originally developed for the high-altitude Wellington bomber variant, the two-stage supercharger represented sophisticated engineering that addressed the fundamental challenge of maintaining engine power at high altitude. The first stage compressed incoming air and forced it through an intercooler that reduced its temperature, preventing detonation and allowing higher boost pressures. This cooled, compressed air then entered the second supercharger stage for additional compression before finally entering the engine's cylinders. The result was an engine that maintained robust power output to altitudes exceeding 30,000 feet, fundamentally transforming the Spitfire's high-altitude combat capability. But the Merlin 61 engine was substantially heavier and longer than the Merlin 45 it replaced, creating significant design challenges. The additional weight forward of the center of gravity required careful rebalancing to maintain the Spitfire's renowned handling characteristics. Supermarine engineers lengthened the fuselage slightly and revised the tail section to restore proper balance and stability. The larger engine required a modified cowling with a more prominent air intake beneath the spinner to feed the intercooler's cooling requirements. These changes altered the Spitfire's distinctive profile subtly but noticeably to observers familiar with earlier variants. The first Spitfire 9s began reaching operational squadrons in July 1942, providing Royal Air Force Fighter Command with an aircraft capable of meeting the Bf 109 Gustavs and FW-190 on equal terms at all altitudes. Production accelerated rapidly throughout late 1942 and into 1943 as factories converted from building Mark Vs to producing the superior Mark 9 variant. By mid-1943, when Watkins flew his ill-fated mission over France, the Mark 9 had become the standard equipment for most Royal Air Force fighter squadrons operating over northwestern Europe. German intelligence had tracked the Spitfire 9's introduction and deployment through combat reports, photographic reconnaissance, and the interrogation of captured Royal Air Force personnel. But intelligence reports based on fragmentary observations during chaotic combat conditions could not provide the detailed, systematic understanding that came from having an intact example available for comprehensive ground examination and flight testing. The recovery of Watkins's Spitfire offered precisely that opportunity, and German technical intelligence personnel recognized its value immediately. The salvage team worked carefully to extract the crashed fighter from its resting place without causing additional damage that might compromise its intelligence value. Using jacks and wooden supports, They carefully rolled the inverted aircraft back onto its landing gear, a delicate operation that required hours of patient work. Once upright, the Spitfire's damage could be properly assessed. The left wing had sustained severe battle damage and impact damage, rendering it unrepairable. The propeller was destroyed completely. The tail section had separated but remained largely intact. However, the fuselage, right wing, cockpit, and most critically, the Merlin 61 engine showed damage that appeared repairable, given sufficient time, parts, and skilled labour. The decision was made to transport the entire aircraft to Rechlin, the Luftwaffe's primary testing and evaluation facility located in Mecklenburg, approximately 100 kilometers northwest of Berlin. Rechlin had been designated the Luftwaffe's official central testing facility since February 1936, and possessed the most comprehensive test facilities, most experienced technical personnel, and largest inventory of spare parts cannibalized from other captured Allied aircraft. If any facility could restore this Spitfire to flying condition, it was Rechlin. Transportation presented significant logistical challenges. The Spitfire had to be partially disassembled to fit on standard flatbed rail cars used for transporting damaged aircraft across occupied Europe. The wings were removed and secured separately. The tail section was loaded as a distinct unit. The fuselage, with engines still installed, formed the largest single component. The entire load, carefully covered with tarps to protect it from weather and prying eyes, began its journey eastward through France and into Germany, moving at night when possible to avoid attracting attention from Royal Air Force fighter bombers that increasingly ranged across occupied territories, attacking targets of opportunity. The journey took nearly 2 weeks, the train moving in fits and starts through a transportation network increasingly strained by the demands of total war. But eventually, the wreckage arrived at Rechlin, where it was received by a specialized team of technicians, engineers, and test pilots who had spent years evaluating captured Allied aircraft and developing tactical recommendations for Luftwaffe operational units. These men approached their work with professional curiosity and systematic methodology that transcended propaganda and political ideology. They sought objective understanding of Allied aircraft capabilities through direct observation and controlled testing, knowing that German pilots' lives depended on accurate intelligence rather than comforting lies. The Spitfire was moved into one of Rechlin's large workshops, where teams immediately began detailed examination and documentation. Every aspect of the aircraft was photographed extensively from multiple angles. Measurements were taken of critical dimensions. The engine was carefully removed for separate examination and testing. Panels were opened to reveal internal structure and systems. Technical drawings were created documenting construction methods, material selections, and design approaches. This systematic documentation would inform German aircraft designers and provide baseline intelligence even if the aircraft could not be restored to flying condition. But restoration remained the primary objective, because flight testing would reveal performance characteristics, handling qualities, and operational capabilities that could never be fully understood through ground examination alone. The repair work began with assessment of what components could be salvaged from the crashed aircraft and what would need to be fabricated or cannibalized from other Spitfire wrecks in Rechlin's substantial inventory of crashed Allied aircraft. The left wing was beyond repair, but Rechlin possessed a complete wing assembly recovered from another Spitfire 9 that had crashed in Holland 2 months earlier. That wing, carefully stored and protected, could be mated to Watkins's fuselage after appropriate modifications. The Merlin 61 engine required extensive work. Technicians completely disassembled the power plant, laying out hundreds of components for individual inspection and assessment. Cylinder heads were examined for cracks. The crankshaft was checked for straightness using precision measuring equipment. The supercharger assemblies were carefully inspected for damage or wear that might affect their critical function of maintaining power at altitude. Numerous components needed replacement with parts cannibalized from other Merlin engines in varying states of repair. The 2-stage supercharger system particularly fascinated German engineers who examined it in meticulous detail. They recognized immediately that this sophisticated arrangement solved the high-altitude power problem that plagued German inline engines, which relied on mechanically driven single-stage superchargers that consumed increasing amounts of power at altitude. The intercooler between supercharger stages represented elegant engineering that prevented excessive charge, temperature, while allowing higher boost pressures. German engine designers had explored similar concepts, but had not yet implemented them successfully in operational engines due to development challenges and resource constraints. The hydraulic system underwent complete rebuilding after the battle damage that had forced Watkins's emergency landing. Hydraulic lines were replaced throughout the aircraft. Actuators were tested and rebuilt as necessary. The undercarriage received particular attention since proper functioning would be critical for landing the repaired aircraft safely. Merlin's technicians fabricated a new propeller assembly using a hub and blades from various sources, matching them as closely as possible to original specifications. The cockpit instruments were examined, tested, and recalibrated where necessary. Weeks stretched into months as the restoration progressed slowly but steadily. Skilled technicians worked with remarkable dedication despite Germany's increasingly a difficult strategic situation, and the growing Allied bombing campaign that periodically disrupted work and diverted resources to more immediately critical priorities. The Spitfire gradually transformed from wreckage to potentially flyable aircraft through hundreds of hours of patient labor by men who took professional pride in their work, regardless of which nation had built the machine they were. Restoring. By September 1943, approximately 3 months after Watkins's forced landing, the Spitfire 9 had been declared ready for initial ground tests. The Merlin 61 engine was run extensively on the ground, its performance carefully monitored while technicians verified that all systems functioned properly under power. Oil pressure, coolant temperature, fuel flow, and electrical generation all checked within acceptable parameters. The hydraulic system raised and lowered the landing gear repeatedly without problems. Control surfaces moved freely through their full range of motion. The aircraft received German markings for identification during flight operations, preventing German pilots from mistaking it for an enemy aircraft during test flights when it would be operating from German airfields. The fuselage bore a simple number code, the wings displayed German crosses, and the entire tail section was painted in bright yellow according to standard Luftwaffe protocols for captured aircraft. These markings transformed the Spitfire's appearance dramatically, making it seem alien and wrong, a proud symbol of the Royal Air Force forced into enemy colours through the fortunes of war. Finally, in late September 1943, the restored Spitfire 9 was rolled out onto Merlin's main runway for its first test flight under German control. The test pilot selected for this critical flight was Hauptmann Wolfgang Speth, an experienced Luftwaffe officer with thousands of flight hours and extensive experience testing both German and captured Allied aircraft. Speth approached the assignment with professional interest mixed with healthy caution, knowing that restored crashed aircraft sometimes harbored hidden damage or problems that only revealed themselves in flight with potentially fatal consequences. Speth walked around the Spitfire slowly during his pre-flight inspection, examining the aircraft with the practiced eye of a pilot whose survival depended on noticing details that others might overlook. He checked control surface travel, looking for binding or unusual resistance. He examined the tires for proper inflation and signs of damage. He peered into the engine cowling, verifying that nothing looked obviously wrong with the installation. He tested the propeller blades, pushing against them to ensure they were properly secured to the hub. Every step followed a mental checklist developed through years of flying high-performance aircraft, where mechanical failure often meant death. The cockpit felt immediately foreign as he settled into the seat and began familiarizing himself with the layout. Everything was labeled in English, the instruments arranged according to Royal Air Force standards rather than Luftwaffe conventions. The throttle operated in the opposite direction from German fighters, forward for power rather than backward. The fuel cock positions were marked differently. The oxygen system controls bore unfamiliar markings. Even the seat felt different, positioned slightly higher and angled differently than what he was accustomed to in the Messerschmitt Bf 109 he normally flew. Spete spent several minutes simply sitting in the cockpit with the engine shut down, moving controls and memorizing their positions, building the muscle memory that would allow him to operate the aircraft instinctively during flight, when there would be no time for conscious thought about which control did what. He practiced the throttle movement repeatedly, forcing himself to internalize that forward meant more power in this aircraft. He located the undercarriage control and verified its operation. He found the flap lever and tested its range of motion. He identified the fuel tank selector and the primer pump and the magneto switches. Ground crew members stood by with fire extinguishers, while Spete went through the engine start procedure, following the checklist that Merlin's technicians had prepared based on captured Royal Air Force technical manuals and their own experience with the Merlin engine. The starter engaged with a mechanical whine, turning the propeller slowly at first, then faster as the engine began to fire. Individual cylinders caught and fired irregularly, the engine coughing and stumbling before finally settling into a rough idle. Blue smoke drifted back from the exhaust stacks, gradually clearing as the engine warmed and smoothed out. Spete monitored the instruments carefully as the Merlin warmed up, watching oil pressure climb into the normal range, observing coolant temperature rise steadily, verifying that fuel pressure remained stable. The engine note changed as he advanced the throttle slightly, the deep rumble increasing in pitch and volume. Everything appeared normal, the engine running smoothly without unusual vibrations or concerning noises. He looked up at the sky, clear blue with scattered clouds at around 10,000 feet, perfect conditions for a first test flight. He signaled the ground crew that he was ready to taxi, released the brakes, and added a touch of power. The Spitfire rolled forward smoothly, responding to rudder inputs as he guided it toward the runway. The tailwheel steering felt different from German aircraft, more responsive and direct. Visibility over the nose was restricted by the long engine cowling, requiring him to S-turn during taxi to see ahead, a technique familiar from flying the Bf 109, but requiring adjustment to the Spitfire's specific sightlines and turning radius. At the runway threshold, Spete performed his final checks methodically, testing each control surface for full and free movement, verifying that instruments showed normal readings, confirming that the fuel selector was positioned correctly and the mixture was properly set. His heart rate had increased noticeably, adrenaline sharpening his senses as it always did before flying something new and potentially dangerous. But his hands remained steady on the controls, his breathing controlled and even. Fear could be acknowledged and managed, but never allowed to dominate decision-making. He advanced the throttle smoothly, feeling the Merlin engine respond with that characteristic rising howl that Spitfires made under power. The acceleration was brisk and linear, the aircraft tracking straight down the runway with only minor rudder corrections needed to counteract the engine torque. The tail came up quickly, improving forward visibility dramatically. Airspeed increased rapidly as painted runway markers flashed past, 50 miles per hour, 70, 90. At 110 miles per hour, Spete eased back on the stick and the Spitfire lifted off smoothly, climbing away from Merlin with surprising eagerness. The landing gear came up cleanly with a reassuring thump as the wheels locked into their wheel wells. Spete maintained a steady climb, circling the airfield while gaining altitude, keeping the facility in sight in case immediate landing became necessary due to mechanical problems. But the Spitfire climbed steadily and smoothly, the Merlin engine running perfectly, all instruments showing normal readings. At 5,000 feet, Spete leveled off and began gentle exploratory maneuvers, getting a feel for how the aircraft responded to control inputs. The first thing that struck him was the lightness and precision of the controls compared to the Bf 109 he regularly flew. The stick forces were beautifully balanced, requiring neither excessive effort nor overly delicate touch. A gentle input produced smooth, predictable response without over-controlling. The ailerons were particularly impressive, providing roll rates that exceeded anything he had experienced in German fighters. He could snap the Spitfire from hard left bank to hard right bank almost instantaneously, the wings rotating around the longitudinal axis with remarkable crispness. The rudder felt powerful and effective, providing excellent directional control without being overly sensitive or requiring excessive foot pressure. The elevator response was similarly well harmonized, allowing precise pitch control throughout the speed range he had explored so far. Spete began to understand why Royal Air Force pilots spoke so reverently about their Spitfires. This was an aircraft designed with genuine understanding of what pilots needed in combat, where the difference between life and death often came down to fractions of a second and inches of positioning. He climbed higher, taking the Spitfire up through 10,000 feet, 15,000, 20,000 feet, monitoring the engine performance carefully as altitude increased and air density decreased. German fighters equipped with single-stage superchargers typically began showing noticeable power loss above 18,000 feet, their engines struggling to breathe in the thinning atmosphere. But the Spitfire 9's Merlin 61, with its sophisticated two-stage supercharger, showed no such weakness. The engine continued pulling strongly, the climb rate remaining robust even as Spate passed through 25,000 feet. This altitude performance represented exactly the capability that had made the Spitfire 9 such a significant threat to Luftwaffe operations. German fighter bombers conducting high-altitude raids over England had initially enjoyed a substantial performance advantage over Spitfire 5s that struggled above 20,000 feet. But the introduction of the Mark 9 had eliminated that advantage completely, forcing German aircraft to fight at altitudes where they no longer held any performance edge and often operated at a distinct disadvantage. At 25,000 feet, Spate leveled the Spitfire and began more aggressive maneuvering, pushing the aircraft harder to explore its handling characteristics at altitude. He rolled into a steep turn, pulling back firmly on the stick to maintain altitude as G-forces built. The Spitfire responded beautifully, carving a tight circle through the thin air, with none of the mushiness or unwillingness that characterized many fighters at this altitude. The controls remained crisp and responsive, requiring only slight increase in stick force compared to low-altitude handling. He reversed the turn sharply, snapping the stick across and applying opposite rudder. The Spitfire rolled rapidly through inverted and into the opposite turn without hesitation or any tendency toward departure from controlled flight. Spete could feel the aircraft's stability through the controls, the way it wanted to fly smoothly and predictably rather than fighting him or displaying dangerous characteristics. This was a forgiving aircraft that would allow average pilots to survive their mistakes while enabling skilled pilots to extract exceptional performance. Spate pushed the nose down and let the Spitfire accelerate in a shallow dive, building speed rapidly as gravity and power combined to overcome drag. The airspeed indicator needle swept past 300 miles per hour, 350. 400. At 420 miles per hour, he began a pull-up, applying back pressure gradually to avoid overstressing the airframe. The G-forces built smoothly as the Spitfire arced upward, pressing him down into the seat with increasing weight. The aircraft remained rock-solid throughout the maneuver, showing no tendency toward flutter or buffet that would indicate approaching structural limits. He climbed back to 25,000 feet and began a series of stalls, testing how the aircraft behaved at the edge of its performance envelope. With the throttle at idle and the nose pitched up, the Spitfire slowed gradually, the airspeed bleeding off as the wings approached their critical angle of attack. At around 80 miles per hour, the aircraft gave clear warning of the approaching stall through gentle buffeting that shook the airframe and transmitted through the controls. Spate maintained back pressure, and the Spitfire broke clean and honest, the nose dropping straight ahead without any tendency to snap, roll, or spin. Recovery was immediate and simple, requiring only relaxation of back pressure and application of power. The aircraft accelerated quickly back to flying speed, with no drama or difficulty. Spate repeated the stall several times with different configurations: flaps down, turning stalls, accelerated stalls, building a complete picture of the Spitfire's behavior throughout its flight. Envelope. In every case, the aircraft behaved predictably and forgivingly, exactly the characteristics needed in a combat fighter, where pilots often operated at the edge of controllability while maneuvering violently to gain advantage or avoid being shot down. After 45 minutes of systematic testing at altitude, Spate descended back toward Rechlin for landing, his mind processing everything he had experienced during the flight. The Spitfire represented genuinely impressive engineering, incorporating lessons learned through years of combat experience and evolutionary development. The British had created a fighter that excelled at precisely the mission profile that mattered most in the air war over Western Europe: high-altitude interception and escort operations, where engine performance above 20,000 feet determined tactical success or failure. The landing pattern felt natural and comfortable, despite his relative unfamiliarity with the aircraft. Spate lowered the landing gear and extended the flaps, feeling the Spitfire slow and settle into approach configuration. The view over the nose remained somewhat restricted, requiring him to fly a curving approach that kept the runway visible to one side until very late in the pattern. But the handling remained crisp and predictable at approach speeds, the aircraft responding immediately to control inputs without any tendency toward dropping a wing or exhibiting other unpleasant low-speed characteristics. He crossed the runway threshold at 90 miles per hour and began reducing power, allowing the Spitfire to settle toward the concrete surface. The main wheels touched smoothly, and Spate held the tail up briefly before allowing it to settle onto its tail wheel. The rollout was straight and controlled, requiring only light brake applications to bring the aircraft to taxiing speed. As he turned off the runway and headed back toward the hangar, Spate allowed himself a moment of satisfaction. The test flight had been completely successful, revealing no hidden problems or dangerous characteristics. The Spitfire was fully airworthy and ready for more comprehensive evaluation. Over the following weeks, Spate and other experienced Luftwaffe test pilots flew the captured Spitfire 9 extensively, systematically mapping its performance envelope and comparing it directly with German fighters under controlled conditions. They conducted timed climbs to various altitudes, recording the exact time required to reach specific heights and comparing these figures with similar data for the Bf 109 Gustav and the Focke-Wulf FW 190 Anton. The results confirmed what combat pilots had been reporting from actual engagements. The Spitfire 9 could outclimb both primary German fighter types at all altitudes, with the performance gap becoming particularly pronounced above 20,000 feet, where the two-stage Merlin's superiority became overwhelming. Speed trials at various altitudes revealed that the Spitfire 9 possessed a maximum speed of approximately 408 miles per hour at 25,000 feet, slightly faster than the Bf 109 Gustav and comparable to the FW 190 Anton at that altitude. But the Spitfire maintained its speed advantage at higher altitudes, where German fighters struggled increasingly with power loss. At 30,000 feet, the Spitfire retained strong performance, while German fighters laboured with significantly reduced power output, giving Royal Air Force pilots a decisive advantage in combat that occurred at extreme altitudes. Turn performance testing produced more nuanced results that required careful analysis to understand properly. In sustained level turns at moderate speeds and altitudes, the Bf 109 could match or slightly exceed the Spitfire 9's turn rate, particularly when the Messerschmitt's leading-edge slats deployed automatically and delayed wing stall during tight manoeuvring. The Luftwaffe 190, while less capable in sustained turning than either the Spitfire or Bf 109, possessed excellent roll rate that allowed it to change direction rapidly through aggressive use of ailerons. However, German test pilots discovered that focusing solely on sustained turn performance missed the larger tactical picture. The Spitfire 9 excelled at what fighter pilots call energy management, the ability to convert speed to altitude and altitude back to speed efficiently throughout combat maneuvering. In dynamic combat involving constant changes in speed, altitude, and direction, the Spitfire's superior power-to-weight ratio and aerodynamic efficiency allowed skilled pilots to maintain energy state, while German fighters bled energy during maneuvering. This energy advantage proved tactically decisive because it allowed Spitfire pilots to dictate engagement terms according to their preferences. They could choose when to engage, attacking from advantageous positions using superior climb rate to gain altitude or superior speed to close quickly. Equally important, they could choose to disengage from unfavorable situations, using their performance advantages to extend away from German fighters that lacked the capability to pursue effectively. German pilots discovered they could rarely force combat on a Spitfire 9, whose pilot recognized an unfavorable tactical situation and elected to avoid engagement. Dive performance tests revealed another area where the Spitfire demonstrated clear superiority. The aircraft could dive at very high speeds without encountering the severe compressibility effects and control stiffening that plagued many fighters when approaching their maximum design speeds. German test pilots pushed the Spitfire into near-vertical dives, building speed until the airframe began showing signs of stress through vibration and control heaviness. But even at these extreme speeds, approaching the aircraft's structural limits, the controls remained effective, and the pilot could pull out of the dive without requiring superhuman strength or fighting controls that had locked solid. The Bf 109, by contrast, suffered from increasingly severe control problems in high-speed dives. The elevator became progressively heavier as speed increased, eventually requiring both hands on the stick and tremendous physical effort to pull out of steep dives. Some pilots had actually died when they were unable to generate sufficient force to overcome the control loading and pulled their aircraft out of terminal dives before impacting the ground. The Spitfire's much lighter and more effective elevator control at high speed represented a significant safety advantage that directly translated into tactical flexibility during combat. German engineers examining the Spitfire's structure and systems found much to admire in its design, philosophy, and execution. The aircraft was substantially built with significant structural strength engineered throughout the airframe. The famous elliptical wing, while more complex to manufacture than simpler straight-tapered designs, provided excellent aerodynamic efficiency across a broad speed range and generated substantial lift with minimal drag. The stressed skin construction was sophisticated and well executed, distributing loads efficiently throughout the structure. The cockpit layout impressed German pilots familiar with the cramped, poorly arranged cockpit of the Bf 109. The Spitfire provided significantly better visibility in most directions, more comfortable seating that reduced pilot fatigue during long missions, and instruments that were logically grouped and clearly marked. The canopy could be jettisoned quickly in emergencies, and the seat was positioned to provide good sight lines for both instrument scanning and external visual search. These human factors considerations might seem minor compared to raw performance numbers, but they significantly impacted pilot effectiveness during actual combat operations, where situational awareness and reduced workload often determined survival. The Merlin 61 engine received extensive examination and testing, with German engineers carefully documenting every aspect of its design and operation. They were particularly impressed by the robust reliability the engine demonstrated despite its high performance and sophisticated supercharging system. The two-stage supercharger with its intercooler represented elegant engineering that solved the altitude performance problem through mechanical means, rather than requiring exotic fuels or operating conditions. The engine could run for extended periods at high power settings without overheating or suffering mechanical problems, a testament to sound design and quality manufacturing. German engine designers recognized that replicating this capability in their own engines would require substantial development time and resources that Germany's deteriorating strategic situation made increasingly difficult to allocate. The Daimler-Benz DB 605 engine that powered the Bf 109 Gustavs was already being pushed to its design limits through progressively higher boost pressures and revisions that increased power output, but often reduced reliability and service life. Developing an entirely new engine with two-stage supercharging comparable to the Merlin 61 would take years and require manufacturing capacity that was already strained beyond sustainable levels. The captured Spitfire 9 also provided German intelligence with valuable information about Royal Air Force operational procedures, maintenance practices, and pilot training methods through careful examination of the aircraft's condition and configuration. The logbook entries in captured documents revealed the aircraft's service history. The wear patterns on various components indicated how the Royal Air Force maintained its fighters. The quality of workmanship in field repairs showed the skill level of ground crews. Even small details, like the type of paint used, the quality of fasteners, and the precision of manufacturing tolerances, provided insights into British industrial capabilities and technical standards. As autumn turned to winter in 1943, the captured Spitfire 9 continued flying regularly from Rechlin, participating in various evaluation programs and demonstration flights. German fighter pilots selected for transition training to new aircraft types would often fly mock combat missions against the Spitfire to familiarize themselves with its capabilities and limitations before encountering the type in actual combat. These controlled engagements provided invaluable experience that helped German pilots understand what they would face operationally and develop tactics that maximized their own aircraft's remaining advantages, while avoiding situations where the Spitfire's superiorities would prove decisive. The demonstrations at operational Luftwaffe bases began in earnest during late 1943 and continued throughout 1944 as the captured Spitfire 9 travelled extensively across Germany and occupied territories. These visits followed a carefully structured program designed to maximize educational value for frontline fighter pilots who would soon face Spitfires in actual combat, where mistakes cost lives, and superior knowledge provided critical advantages. The program recognized that theoretical briefings and written intelligence reports, while valuable, could never replace the visceral impact of watching an enemy aircraft perform maneuvers directly overhead or sitting in its cockpit and understanding firsthand how British pilots saw the world through their gun sights. Each base visit typically lasted 2 to 3 days, allowing sufficient time for comprehensive demonstrations and individual pilot consultations. The program began with the Spitfire arriving at the host base, usually flying in under its own power with German markings clearly visible to prevent tragic friendly fire incidents. The sight of this distinctively shaped aircraft, so familiar as an enemy but now wearing German crosses and identification markings, created immediate psychological impact that captured attention more effectively than any lecture or briefing ever could. Pilots would emerge from their ready rooms and barracks to watch the Spitfire taxi past, seeing details that could never be observed during fleeting combat encounters, when both aircraft hurtled past each other at combined closing speeds, exceeding 600 miles per hour. Ground demonstrations allowed pilots and maintenance personnel to examine the aircraft intimately, opening panels to inspect internal structure, sitting in the cockpit to understand the pilot's perspective, and asking detailed questions of the test pilots who had accumulated hundreds of hours flying captured Allied fighters. These sessions revealed details that proved invaluable for combat effectiveness. Pilots learned exactly where the Spitfire's fuel tanks were located, knowledge that informed gunnery tactics about where to concentrate fire for maximum effect. They observed the positions of critical systems like hydraulic lines and coolant passages, understanding which areas of the aircraft were most vulnerable to battle damage. They noted the ammunition capacity and gun positions, information that helped predict how long a Spitfire could maintain effective fire during combat. The cockpit examination sessions proved particularly educational, allowing German pilots to understand Royal Air Force operational procedures and pilot workload through direct observation of controls and instruments. They noted how British pilots managed engine settings during different flight regimes. They observed the fuel management system and understood how Spitfire pilots switched between internal tanks and external drop tanks during extended missions. They examined the gun sight and understood how British pilots aimed their weapons. This knowledge demystified the enemy, transforming Spitfires from abstract threats into understandable machines flown by men who faced similar challenges and operated under comparable constraints. Flying demonstrations showcased the Spitfire's capabilities in ways that left lasting impressions on observers who watched from the ground or from the cockpits of their own aircraft flying in formation. Test pilots would begin with basic maneuvers that displayed fundamental characteristics, climbing steeply to demonstrate the Spitfire's excellent climb rate, accelerating in level flight to show its impressive speed, rolling rapidly to exhibit exceptional aileron effectiveness. These initial demonstrations established baseline understanding before progressing to more complex tactical maneuvers that illustrated how Royal Air Force pilots employed these capabilities in actual combat. Mock dogfights against German fighters provided the most valuable component of each demonstration, allowing selected, experienced pilots to engage the Spitfire under controlled conditions, with safety observers monitoring to prevent accidents while ensuring realistic tactical scenarios. These encounters followed carefully planned scripts designed to illustrate specific tactical situations and highlight both Spitfire advantages and the limited circumstances where German fighters retained exploitable edges. A typical scenario might begin with altitude advantage to the German fighter, simulating the bounce from above that represented standard Luftwaffe doctrine for engaging enemy fighters and bombers. The German pilot would roll into a diving attack, building speed rapidly as gravity accelerated his aircraft toward the Spitfire cruising below. But as he approached firing position, the Spitfire pilot would see the attack developing and initiate a climbing turn, using the Mark Nine's superior climb rate and excellent high-altitude performance to gain altitude while turning into the attack. The German pilot would attempt to follow, pulling his Bf 109 or Fur 190 into a climbing pursuit. But the Spitfire would outclimb him steadily, reaching higher altitude and reversing the tactical situation within 30 seconds of sustained climbing combat. Now the Spitfire held the altitude advantage, positioning above and behind the German fighter, whose initial advantage had been completely negated. The German pilot might attempt to dive away, using gravity to build speed and extend outside the Spitfire's engagement envelope. But the Spitfire would simply follow him down, its excellent dive characteristics allowing it to maintain close pursuit, while the German fighter struggled with progressively heavier controls as speed increased. Unable to shake his pursuer through diving, unable to outclimb the superior British fighter, unable to outrun an aircraft with higher maximum speed, the German pilot found himself in an impossible tactical situation, with no good options remaining. Alternative scenarios explored different tactical situations, demonstrating the Spitfire's capabilities across various combat geometries. Head-on passes showed how quickly the Spitfire could reverse direction using superior roll rate, converting a neutral merge into an advantageous position within seconds. Scissors maneuvers demonstrated how the Spitfire's energy management allowed it to maintain speed and altitude throughout violent direction changes, while German fighters bled energy rapidly. Vertical fights illustrated how the two-stage Merlin's power advantage enabled the Spitfire to sustain vertical maneuvering that German fighters simply could not match above 20,000 feet. These mock combat sessions delivered sobering lessons to German pilots who had perhaps harbored hopes that their training, experience, or tactical doctrine might compensate for aircraft performance disadvantages. Directly experiencing the Spitfire's capabilities removed any comfortable illusions about competitive parity. The reality was undeniable and impossible to rationalize away through wishful thinking or propaganda. Royal Air Force pilots flying Spitfire 9s possessed significant performance advantages in almost every category that mattered for high-altitude air combat, and no amount of courage, skill, or tactical cleverness could fully overcome those fundamental imbalances. Following the flying demonstrations, detailed debriefing sessions allowed test pilots to share specific tactical recommendations developed through extensive experience flying both German and Allied fighters. These recommendations represented practical survival knowledge, distilled from hundreds of hours of comparative testing and mock combat. German pilots learned to avoid sustained climbing engagements against Spitfires above 20,000 feet, where the British aircraft's engine advantage became overwhelming. They learned to recognize when a Spitfire pilot was attempting to force them into energy-depleting maneuvers, and how to refuse that trap by maintaining speed and extending outside engagement range. They learned the importance of maintaining awareness of their own energy state throughout combat, understanding that losing too much speed or altitude against a Spitfire often proved fatal, because regaining that lost energy required time and space that an aggressive opponent would never grant. They learned specific techniques for breaking off engagement when tactical conditions turned unfavorable, using the limited advantages their aircraft retained, particularly the Bf 109's slightly superior sustained turn rate at lower altitudes, to create separation opportunities. They learned to fight as teams rather than individuals, using mutual support to compensate for individual performance disadvantages and create tactical situations where numerical advantage could offset the Spitfire's technical superiorities. But these tactical recommendations, while genuinely valuable, could not change the fundamental calculus of air combat over Western Europe during 1944. German fighter pilots remained outnumbered, outperformed, and increasingly overwhelmed by Allied air superiority that manifested across every dimension of aerial warfare. The Spitfire 9 represented just one component of that superiority. Joined by the American P-51 Mustang with its extraordinary range, the rugged Republic P-47 Thunderbolt with its devastating firepower, and growing numbers of other Allied fighters that collectively strangled the Luftwaffe's ability to contest control of the air. The psychological impact of these demonstration programs extended beyond tactical education to affect German pilot morale in complex and sometimes contradictory ways. Some pilots found the knowledge empowering, feeling better prepared for a combat through realistic understanding of what they would face. Others found the demonstrations deeply demoralizing, recognizing with painful clarity the magnitude of disadvantages they would carry into every engagement. Most experienced both reactions simultaneously, appreciating the value of the information while being sobered by its implications for their own survival prospects. Letters and diary entries from German fighter pilots during this period frequently mention the profound impression made by seeing captured Allied fighters demonstrate capabilities that exceeded German aircraft across multiple critical performance categories. One pilot wrote of watching a Spitfire effortlessly outclimb 3 Bf-109s in a demonstration flight, describing the sick feeling in his stomach as he realized that Royal Air Force pilots enjoyed similar advantages during actual combat. Another pilot's diary recorded his thoughts after sitting in a captured Spitfire's cockpit, noting the comfortable ergonomics, excellent visibility, and thoughtful instrument layout that seemed to reflect a design philosophy that actually prioritized pilot effectiveness, rather than simply accepting whatever configuration resulted from engineering compromises. These observations carried uncomfortable implications about relative national capabilities that extended well beyond aircraft design. German propaganda had consistently portrayed British engineering as adequate but uninspired, emphasizing German technical superiority as self-evident fact, requiring no supporting evidence. But direct experience with aircraft like the Spitfire 9 challenged those comfortable assumptions, forcing acknowledgement that British designers and engineers had created genuinely excellent aircraft that matched or exceeded German capabilities in areas that mattered strategically. This realization undermined confidence in broader propaganda narratives about Allied inferiority and German inevitable victory, contributing to declining morale that reflected growing recognition of strategic reality. The captured Spitfire program also provided valuable intelligence about Royal Air Force operational practices and pilot training methods through careful analysis of how the aircraft had been configured, maintained, and operated before its capture. German intelligence officers examined every detail for insights into British procedures and capabilities. The condition of the aircraft when captured suggested high maintenance standards and well-trained ground crews. The logbook entries revealed training progression and operational patterns. Even small details like the type of oxygen equipment, the radio frequencies programmed into the communications system, and the personal effects left in the cockpit by the unfortunate Flight Lieutenant Watkins provided fragments of information that contributed to building comprehensive intelligence pictures. Technical intelligence gathering extended to detailed engineering analysis of components and systems, with German engineers carefully documenting construction methods, material selections, and manufacturing techniques throughout the captured Spitfire. They examined how British factories produce the complex elliptical wing structure efficiently, despite its geometric complexity. They studied the stressed skin construction methods that distributed loads effectively while maintaining relatively light weight. They analyzed the quality of aluminum alloys used in various structural components, noting that British metallurgy produced materials that equaled or exceeded German standards despite Germany's supposed technical superiority in materials science. The fuel system received particular attention as engineers attempted to understand how British designers had achieved reliable operation across the aircraft's full performance envelope. Despite the challenges of maintaining fuel flow, during violent maneuvering at various altitudes. The hydraulic system was analysed for its reliability and maintainability characteristics. The electrical system was examined to understand British approaches to circuit protection and wire routing. Every system and component was studied systematically, with findings documented in detailed technical reports that circulated among German aircraft designers and manufacturing engineers. Manufacturing quality impressed German engineers who had grown accustomed to declining production standards, as Germany's strategic situation deteriorated and forced the use of substitute materials, undertrained labour, and dispersed production facilities. The Spitfire demonstrated consistently high manufacturing quality throughout its structure, with tight tolerances maintained even in components that experienced significant stress during operation. Riveting was neat and precise, surfaces were smooth and well finished, and assemblies fit together properly without requiring extensive field modifications or adjustments. This quality reflected British industrial capabilities that had adapted successfully to wartime production demands without sacrificing standards that affected operational effectiveness and aircraft longevity. The contrast with late-war German fighter production grew increasingly stark as 1944 progressed and Allied strategic bombing intensified pressure on German industry. Aircraft rolling off production lines showed progressively more evidence of hasty assembly, substitute materials, and quality compromises forced by resource constraints and dispersed manufacturing. Paint finishes became rougher, surface smoothness deteriorated, and components sometimes fit poorly, requiring field modifications before aircraft could be accepted for operational service. These quality problems translated directly into reduced performance, decreased reliability, and higher maintenance requirements that further strained already overtaxed ground crews working with inadequate parts supplies and deteriorating tools. By mid-1944, as Allied forces established themselves in Normandy following the successful D-Day invasion and began their advance toward Germany itself, the captured Spitfire 9 had become something of a legend among Luftwaffe fighter pilots who had either seen it during demonstration visits or heard about it from squadron mates who had participated in the program. The aircraft represented tangible evidence that Allied fighters possessed genuine technical excellence rather than merely overwhelming numerical superiority. This knowledge influenced tactical decision-making at all levels, from individual pilots deciding whether to press attacks against Spitfire formations to commanders planning operational strategies with realistic understanding of capabilities and limitations. The program continued operating into autumn 1944. Despite Germany's increasingly desperate strategic situation and the progressive collapse of organized resistance in France, but as Allied armies advanced deeper into German-held territory and the aerial front moved eastward toward Germany proper, opportunities for safe demonstration flights at forward bases diminished steadily. The risk of the valuable captured aircraft being destroyed on the ground during Allied air raids or lost during ferry flights through increasingly contested airspace grew unacceptable. Eventually, the Spitfire 9 was withdrawn from active demonstration duties and returned to Rechlin for permanent static display and continued technical analysis. The intelligence value extracted from this single captured aircraft over approximately 15 months of active operation proved substantial and multifaceted. Hundreds of German fighter pilots received hands-on education about Spitfire capabilities that improved their tactical awareness and survival prospects during subsequent combat. Engineers gained detailed technical knowledge about British design approaches and present the Thomas manufacturing methods that informed German development programs. Intelligence officers compiled comprehensive assessments of Royal Air Force operational procedures and pilot training methods. All of this knowledge flowed from systematic exploitation of one crashed fighter that might otherwise have simply been scrapped or ignored. Yet for all this intelligence value, the fundamental strategic situation remained unchanged and actually deteriorated progressively throughout 1944. Knowledge about enemy capabilities, while tactically valuable, could not overcome the crushing material disadvantages Germany faced across every dimension of military power. The Luftwaffe understood perfectly well that it confronted opponents with superior aircraft performance, overwhelming numerical advantages, better logistics support, more thorough pilot training, and virtually unlimited industrial capacity. Understanding these disadvantages precisely through programs like the captured aircraft testing initiative did nothing to eliminate them or even significantly reduce their impact on operational outcomes. The captured Spitfire Nine's story ultimately illustrated both the value and the limitations of tactical intelligence in strategic warfare. Professional competence, systematic analysis, and innovative approaches to understanding enemy capabilities all contributed to improving German fighter effectiveness at the margins. But margins matter little when fundamental imbalances dominate the broader strategic picture. German pilots who flew better-informed missions because they understood Spitfire capabilities through demonstration programs still faced overwhelming odds that skilled tactics and superior knowledge could not overcome. They died in their cockpits, or parachuted from burning aircraft at rates that depleted the Luftwaffe's most irreplaceable resource, experienced pilots with the judgment and skill necessary for survival and effectiveness in increasingly hopeless tactical situations. The final disposition of the captured Spitfire 9 remains somewhat unclear due to incomplete records from the chaotic final months of the war in Europe. The aircraft was likely destroyed during an Allied bombing raid against Rechlin during early 1945, though some fragmentary evidence suggests it may have been deliberately demolished by retreating German forces to prevent its recapture by advancing Soviet armies approaching from the east. Either way, the physical aircraft disappeared into the general destruction that consumed much of Germany during the war's final apocalyptic phase. But the knowledge gained from studying and flying that Spitfire survived in the memories and experiences of the German pilots who had encountered it during demonstration visits, in the technical reports compiled by engineers who had examined every aspect of its design and construction, and in the tactical recommendations that had flowed from systematic flight testing and mock combat evaluations. That knowledge represented a permanent contribution to professional understanding of aerial combat and aircraft design that transcended the specific circumstances of its acquisition during humanity's most destructive conflict. The story of German test pilots confronting the Spitfire 9's capabilities and coming to terms with British engineering excellence parallels countless similar moments throughout military history when professional warriors acknowledged opponent competence despite their position as enemies. War forces' confrontation with uncomfortable realities that peacetime allows, avoiding through comforting assumptions and convenient ignorance. The German pilots who flew captured Spitfires could not maintain illusions about Allied technical inferiority when direct experience demonstrated otherwise repeatedly and undeniably. That acknowledgement represented intellectual honesty and professional integrity that deserves recognition even within the context of their service to an evil regime fighting an unjust war. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.